Okay, hello there. Um, so what I want to do in this video is review completing the square where the leading coefficient is 1. Um, and what I mean by that is, the coefficient in front of x squared is just 1. And then after we just do some of those examples really quickly, we'll move on to what happens if your leading coefficient or your a value is not 1. So in this case, it's not 1, obviously. And in this example, it's also not 1. So we have to have a new strategy for trying to put these into vertex form. And remember, once we have it in vertex form, that gives us a lot of information: the maximum value or minimum value, the axis of symmetry, the vertex. It allows us to solve quadratic equations and find x-intercepts much easier. So really a lot of value. So this would be review, this first one. So you may be able to just do these problems without the video, but then you can check your answer or just skip ahead. But I'll go through it just for the sake of it. And so remember that really what we want is to just have the 1x squared plus whatever bx is. So we're going to add 7 to both sides, just move this constant out of the way over here. And that gives us y plus 7, leave it a little space, is equal to x squared plus 8x. Now I know to make a perfect square trinomial that I need to add b over 2 squared. And b in this case is 8, so that's 8 over 2 squared. 8 over 2 is 4, so that would be 4 squared, which is 16. So 16 is what I need to add here to make a perfect square trinomial, right? And the perfect square trinomial is a trinomial that can be factored to a binomial squared. Well, if I add 16 on that side, I better add 16 over here as well. Otherwise, I've changed my function. So now I'm going to have y plus 7 and 16 makes 23 equals. And now I need to write this as a binomial squared, right? That's the whole point. We're trying to get to vertex form where you have x minus h squared. So x squared plus 8x plus 16, that is x plus 4 squared. Remember that this number 4 should be half of 8, right? Should be half of 8 and the square root of 16. Okay, final thing to do is just to get y by itself and say y equals x plus 4 squared minus 23. Okay, and that is now in vertex form, where my vertex is at -4, comma, -23. I've shifted down -23, or down 23, and to the left 4. No scaling or reflection on this function. Okay, that's sort of the nicest type of problem because my b value was divisible by 2 and my a value is 1. Now over here I've got the same thing essentially, but my b value is not divisible by 2, so that's just a little bit more annoying, but it's no problem. So I'll say, great, y, I don't know why I said annoying, it's just more fun really. Y plus 10 is equal to x squared plus 7x, right? So I'm adding 10 to both sides. Now I'm going to complete the square. What I need to add is 7 over 2 squared, right? That's the b over 2 squared. So I'm going to add 7 over 2 all squared to both sides plus 7 over 2 all squared. So I've got y plus 10 plus, well, 7 over 2 squared would just be 7 squared over 2 squared, just 7 times 7 over 2 times 2, which would be 49/4. And that is going to equal x plus 7 over 2 squared. I can jump straight to this because I know that if I've completed the square correctly, which I have by adding b over 2 squared to both sides, that this should factor to x plus b over 2 all squared, right? This relationship is always the same. If I started with 7 as my b value, this should be 7 over 2. And I know that these two things, these two expressions are equal. Okay, so they're equal in all their differences, as perhaps we would like Americans and humans to be. Okay, well, let's see here. I lost my 7, it looks like. There it is. Here, we've got y plus 10 plus 49 fourths. 10 is 40 fourths, so I'm just going to write that as 40 fourths to get a common denominator. I'm having some issues here with my pen. And that equals x plus 7 over 2 all squared. So this is y plus, I guess that's going to be 89 fourths, is equal to x plus 7 over 2 squared. And then I'll just subtract 89 fourths to get y equals x plus 7 over 2 squared minus 89 fourths. Now that should be the same as y equals x plus 3.5 squared minus, let's see, how many times does 4 go into 80? 20 times, and then there are 2 more, so 22 and a quarter, I think, so minus 22.25 if I'm not mistaken. So either one of these would be good ways to write it. If I've done that correctly. Okay, so this is actually just review. So now we're going to move on to the new stuff, which is a little bit different here. So what's different? The different thing is that we do not have an a value of 1. Okay, so we have to deal with that because over here, we can only complete the square when we're in the form 1x squared plus bx. 1x squared plus bx. That's when we know how to add that b over 2 to get a perfect square trinomial. But if we don't have the 1 here, if we have some other value, then we don't know what to do. So we need to basically deal with that so that we can still follow our same process. And so this is how we're going to do it. First of all, we're going to do the same thing first, then add 17 to both sides to get that out of the way. Now we've got y plus 17 is equal to 2x squared plus 8x. Now in the same way that because we had that subtraction, we added to get it out of the way, we now have multiplication by 2, which we don't want. We want it to be multiplied by 1 so that we can complete the square. So we're going to do the same thing. We're going to divide everything by 2. We're going to divide that by 2, that by 2, and this by 2. Do not try and simplify this. Just leave it because we're going to end up undoing this stuff later. So this is going to give me y plus 17 over 2 is equal to x squared plus 4x. So now I can complete the square because I have my leading coefficient here of a, which is 1. So now I'm going to complete the square in the same way. And remember that completing the square, what that means is adding the value to make a perfect square trinomial that can then be factored to a binomial squared. So I know I need to add b over 2 squared. I could not do that here because I had the coefficient of 2. But now that I've divided my entire equation by 2, and I can now complete the square. So I'm going to add 4 here, and I'm going to add 4 here. Okay. Now I've got y plus 17 divided by 2 plus 4 is equal to x plus 2 all squared, right? Because x squared plus 4x plus 4, I know this is a perfect square trinomial, PS trinomial, PS tri, let's call it. And it will factor to a binomial squared where this value 2 is half of 4 and also the square root of 4. Now I'm basically done, except for I have to solve for y. So to do that, if I look at y, the things that have been done to y, add 17, divide by 2, add 4. So I've got to undo those in the reverse order. Subtract 4, multiply by 2, then subtract 17. Okay, so let's subtract 4. That's going to give me y plus 17 divided by 2 is equal to x plus 2 all squared minus 4. Multiply by 2 times 2 times 2. Make sure you multiply everything by 2. That should give me y plus 17 equals 2 times x plus 2 squared. No need to try and multiply through here because we're trying to leave this thing in vertex form. If you do too much work, you'll just go back to what you had originally. We're trying to leave this now. But it does need to be -8 because we're multiplying that -4 by 2 as well. Finally, we're going to subtract 17, and then we are done. Y equals 2 times x plus 2 squared minus 20, oh boy, 5. Okay, so now you can see that our scale has remained intact. Right, so that should match this value over here, the 2 and the 2, those two match, that's good. And we can see that our vertex now is at -2, -25, right? We've shifted it, the original parent function, to the left 2 and down 25, okay? So that should make sense. So just to recap the steps, you're going to add the constant. You're going to divide by the leading coefficient if it's not 1. And then you're going to complete the square normally. And finally, you're going to solve for y. So let's try that on this problem. If you want to try this on your own and then check your answer, that'd be great. Or if you want to follow along with me, that would also be fine. OK, step 1, subtract the 7. Y minus 7 is equal to -3x squared plus 9x. Step 2, see if your leading coefficient is 1. It's not. It's -3. That leading coefficient is the coefficient of x squared. It's the coefficient of the term with highest degree or highest exponent. So I need to divide by -3. Divide by -3, divide by -3, and divide this entire thing by -3, making sure my fraction bar includes the y and the -7. So now I should have y minus 7 all over -3. Do not try and simplify, just leave that, is equal to x squared minus 3x. Now I am ready to complete the square as I have 1x squared plus bx, right? That is how you know you're ready to complete the square, when your leading coefficient is 1 and then you have some bx. So to complete the square, I need to add b over 2, whoops, all squared. In this case, that is -3 over 2 all squared. Okay, so that's what I'm going to do to complete the square. Now -3 over 2 is -1.5. When you square 1.5, you get maybe 2.25. I'm really bad with decimals. Let's see here. What is 1.5 times 1.5? 2.25? I don't know if that's what I said. Oh, well. Anyways, we're going to add plus 2.25. I don't know why that's looking like that. Whoops. To both sides, plus 2.25. I'm going to erase this just so it's out of our way. Erase this out of our way. Then I should have y minus 7 divided by -3 plus 2.25 is equal to x minus 1.5 all squared. Remember that these are equivalent, right? This is a perfect square trinomial, which factors to this. If I were to multiply this binomial squared out, a bino squared, I would get that perfect square trinomial. So they are in fact equal, right? This is just an algebraic manipulation. They are equal in all their differences, just like we hope to be in the world. Okay, and finally, solve for y. Y minus 7 over -3 equals x minus 1.5 squared minus 2.25. Now I'm going to multiply by -3 and get y minus 7 equals -3 times x minus 1.5 all squared minus, no, not minus, but plus, I've got to do 2.25 times 3. I think that's, let's see, 6.75, so plus 6.75. Then I'll finally add 7 and get y equals negative 3 times x minus 1.5 all squared plus 13.75. Okay, so finally, I have this in vertex form, and I can write a few things. This is the parent function x squared, but scaled vertically by 3, reflected over the x-axis, translated to the right 1.5, and up 13.75. So I can notice all these transformations. I've taken the thing, I've stretched it by 3, I've reflected it upside down, I've moved it to the right and up. So that gives me a lot of information about this function. Okay, that's it. See you soon.